Hello everyone, today we are continuing our conversation regarding our unit circle. At this point you should be comfortable with degrees. We are now going to move into what we call radians. Radians are another way to measure angle measures, and they allow us to again kind of identify these different points along the unit circle, and then we can use those to identify where we're at and what we're referring to. So let's first talk about what a radian is, and then we can talk about how that's related to our circle. So a radian, if you can probably guess, is related to the radius of a circle. Okay? What it really means is how many times does the radius fit along the circle in that angle. Now it's a little bit confusing, so what I want you to kind of visualize this. I'm taking the radius of my circle. Okay, think of if I had like a little string here or something that's this length. I want to then take that radius and I'm going to take it and drape it along the outside of the circle. Okay, now you can see this isn't going to make it very far. Okay, it's going to end up somewhere up in probably this region up here. So what I need to figure out is then how do I take that radius and continue to take more of them and get all the way around the circle. Specifically, how many times does it make it all the way around the circle? Well, now I'm starting to talk about something more geometric. I'm talking about what we call circumference, which in a circle is defined as 2 pi times the radius. So now I'm getting that radius piece in there. So what that tells me is that the radius fits around the circle 2 pi times. So all the way around the circle is going to be what we consider to be 2 pi times the radius. Now the nice thing, and we didn't talk about this in the first video, but with the unit circle, your radius is always 1. So going out to the side here is 1 unit, okay, 1 unit up, 1 unit to the left, 1 unit down. Okay, what that means is then if I start to use this circumference, I know the circumference of this circle now because I can plug the 1 in for r. So all the way around my circle, the circumference is going to be 2 pi. And that's my first radian. Okay? Now, just like we had 0 degrees and 360 degrees, this point over here actually gets 2 names because we can go all the way around, or I can decide not to go anywhere, in which case it would be 0, or we're going to have pi's in all these answers, so you could call it 0 pi as well. Okay? Now, we're going to think of this circle now as being broken into parts. Okay? We're going to use our kind of knowledge of fractions and splitting apart circles to help us. So what I know now is that all the way around the circle is 2 pi. I'm going to start with this point over here, which is halfway around the circle. Well, if all the way is 2 pi, then 1 half of that should just be 1 pi, okay, which is your correct answer. Okay, real quick, I forgot to mention this at the start of the video. You can add these to the same unit circle. My unit circle with degrees is right up here. You can add it to the same one. I'm using a separate one just for clarity, but if you want to add it to the same unit circle, you can. It's helpful to have them all together. Alright, back to radians. So, halfway around is pi. Well, now what I can look at is I can take and I can go half of that, and I'm at the top here. Well, half of 1 pi is going to be 1/2 pi. Now, I can write it as a 1/2 pi. But what we're going to end up with is we're going to end up with lots of fractions here with pi's on the top and numbers on the bottom. Typically, if it's a 1, we're going to simply leave that number off, and we're just going to call it pi over 2. Okay, so this is going to be my value that I use on the top. Okay, now I can start to break those down even more. So I can use the fact that, well, now I know a quarter of the circle is pi over 2. I know that I'm at 1 pi over here. If I go another quarter to the bottom, I'm adding a pi over 2 to a 1 pi, or I'm adding 1/2 to 1. That's like 1/2 or 3 over 2. So we would consider this point at the bottom to be 3 pi over 2. You can think of it like 3 halves. I went 1/2, 2 halves, 3 halves to get to the bottom. 4 halves is all the way around, which gets me back to 2 pi. 4 over 2 is 2. Okay, and that idea of kind of counting by these different portions of pi is that how we fill in the rest of these. So we're going to have 2 different kind of versions that we work with. The first one I'm going to use is the one that splits all of these in half. So if I take a half and I split it in half again, now I get a quarter. So this point in the middle, which was 45 degrees if you want to think of it that way, is now going to be referred to as pi over 4. Okay, and the reason we know it's pi over 4 is I'm going to be able to fit 4 of these into my 1 pi. So this is called a pi over 4, but it's really an eighth of the circle. Okay, I'm going here. I need to go one more, which would go here. So now I'm counting 2 of those. So I'm going to put this on the inside of the circle here. This would be 2 pi over 4. Now 2 pi over 4 is not reduced. If I reduce it, I get 1/2, which is what I already have. So a lot of these are going to end up reducing. I'm going to put the ones that need to be reduced on the inside, and then our final answers will sit on the outside. So 2 pi over 4 goes on the inside. My final answer of pi over 2 is what's on the outside. And if I go another eighth of the circle, another kind of in between here, I end up at this one in the middle. That one's going to be adding one more to the top here, which is going to make this 3 pi over 4, which is reduced. Okay, then I would go one more, which is going to be 4 pi over 4, okay, which again is 1. 4 over 4 is 1, so that one I can reduce out to what I already have. I'm good there. I can go one more, and I'm counting by quarters, so I have one more quarter onto the 4, gives me 5 quarters, or 5 pi over 4. I'm sorry, should have put that on the outside. That one is reduced. I broke my own pattern. If we continue, I would add one more. This one's going to go on the inside. I would have 6 pi over 4, which 6 over 4 reduces to 3 over 2. I can pull a 2 out of both of those. Going the next chunk here into the middle is going to give me a 7, on the outside, 7 pi over 4. And then finally, all the way around would be 8 pi over 4, and 8 over 4 is the same as 2. Okay, so we want to make sure we have those reduced versions, and you can see that I start to hit those points that are in the middle. Now I have an issue, because now I still have all these kind of in-between values that don't quite fit yet. So, we know that originally, we were calling this 30 degrees, 60 degrees, okay, and then I would have 90 up top. So basically I'm getting 3 things to fit in a half, or if I continue, I would have 3 more on this side, so I have 6 things to fit in this 1 pi. So what I'm going to do is I'm going to start to count by pi over 6. Okay, and the reason I'm using 6 again is because I know I can fit 6 of these kind of 30-degree chunks in my 1 pi, or half of my circle. So now I'm going to start by counting pi's over 6's. Well, if I start with 1 here, my next 30-degree jump, which gets me to what we did call 60 degrees, or this next open tick mark, is going to be 2 pi over 6. Well, 2 pi over 6 does reduce, so I'm going to put it on the inside for now. 2 pi over 6, well, 2 over 6 is the same as 1 over 3, or simply pi over 3. Then I can go to the next one. Okay, well, my next 30-degree jump puts me back at the top, but that's going to get me to 3 pi over 6, which if I look, 3 over 6 is the same as 1/2, or pi over 2. So again, just another version that reduces to what I already have. Then I can go the next 30-degree jump, which is going to get me to 4 pi over 6. Well, 4 pi over 6 does reduce as well. Okay, 4 over 6 is the same as 2 over 3, so I'm going to call this 2 pi over 3. Okay, then we do the next one. My next one is going to go to 5 pi over 6, which does not reduce, so we'll throw that one on the outside. Next jump puts me back here at 1 pi because I have 6 pi over 6, which reduces to 1. Then I make my next jump to 7 pi over 6, which does not reduce, so put that over on the outside. Next jump, I jump over the middle one there, and I end up with, 8 pi over 6, which does reduce. 8 over 6 is the same as 4 over 3, so we'll throw this 4 pi over 3. Okay, and then next jump is going to be 9 pi over 6. Well, 9 over 6 does reduce to 3 over 2, so I already have that one as well. Then I'm going to make my jump again, and I end up with 10 pi over 6. Okay, which reduces here to 5 pi over 3. Then I make my next jump again, is going to go to 11. This one's going to go on the outside, 11 pi over 6. Okay, last jump, if I go all the way, I would go from 11 to 12, so this is going to be 12 pi over 6, and 12 divided by 6 is 2, which gets me all the way around my circle. So I now have all of my radians filled in. Now, this is starting to get a little bit cluttered, so I'm going to box in all of my final answers here, because those are the ones that I want to focus on. Okay, anything that's on the outside of the circle here, the insides of the circle are just repeats of what I have on the outside, but they're not reduced, so we like the outside versions better. And these are all of my radians. Okay, so those are all of the radians. That's where they come from. I kind of showed you that process. It would be nice if we talked about some patterns. Now, the patterns here are not as easy as the ones that we use for degrees. Degrees, we have the 30, 15, 15, 30. Easy, good to go. This one is not quite so easy. What I would start to look at is patterns that go kind of with each quadrant. So in my first quadrant, okay, kind of looking here, everything is just a pi on the top. Okay, and I start with my biggest number and I go down. So I have a 4, 6, 3, 2. Okay, now if I take and flip over to the other side of this, okay, on the other half of the circle, the 3s, 4s, and 6s come across. Okay, so I can start to see that those all need to match up. Okay, the nice thing is that those also go down and across as well. So all my over 6s are ending up kind of in a little rectangle here. Okay, and you can see me kind of draw that out. Same thing with my over 4s. Those are all kind of in those same places. And then over 3s, again, same kind of rectangle. Okay, so you can start to kind of track those denominators at least using that. The numbers on top can be a little bit trickier, but there are some patterns here to think about as well. In the second quadrant, they're all one short of making a whole. So I'm 2 over 3 instead of 3 over 3, 3 over 4 instead of 4 over 4, and 5 over 6 instead of 6 over 6. So I'm 1 short on each one of these. I'm 1 over in the third quadrant. So I'm 1 above being a whole here. Okay. Fourth quadrant, I always struggle to come up with something here. I guess you could say that you're 1 short of being 2. So 2 for 6s would be 12. I'm 1 short of that. 2 for 4ths would be 8. I'm 1 short of that. And for thirds would be 6. I'm 1 short of that. So that's probably the easiest one. I won't know if that's necessarily the best option to use. Okay. I'll be honest with you. I don't necessarily look and memorize the patterns of where these are. I pretty much generate it like the way I showed you in your notes. Okay, I start with your pi's over 4s, pi's over 6s, and count all the way through those, and just kind of make sure that I hit every one. Okay, so for me, what I use is your pi over 4s, which are the same thing as your 45 degrees, and your pi's over 6s, which are the same as 30 degrees. Okay, and those 30 degrees will also include your 60 degrees because you'll hit each of those along the way. Okay, so it's your 30s, but it also involves your 60s when you get those. Okay, and you'll also hit all of your main points as well because those fall into those patterns. So that is your radians. Hopefully that makes sense. Next video, we're going to finally talk about the coordinates that go along with this, and kind of how those triangles that I showed you in the first video are actually involved to help us set up the final part of the unit circle.